Okay, I'm going to do 2 examples of integration with long division. All right. First of all, so let's write an integral and talk about how you know if you're going to use long division. Well, let's see. So that's x squared plus x plus 1 over x squared plus 1 dx. Long division is not my go-to. Neither is completing the square. But if you see that it's an improper fraction, so do you see how this is x squared and this is an x squared? So if the numerator is larger or the same as, so the top is greater than or equal to the bottom exponent, then it's an improper fraction. So we're going to use long division, okay? All right. Well, first of all, I'm going to just try u substitution, but think about that in your head. Generally, you let the u sub be the bottom or the inside. There is no inside, so the bottom, x squared plus 1. The derivative of x squared plus 1 is 2x, and that is not the numerator, okay? So let me say that again. U is x squared plus 1. Du is 2x dx. That's not going to work because the whole numerator would have to just be 2x. Okay, so now I'm going to use long division. Leave a blank, x squared plus 1 into x squared plus x plus 1. Okay, x, and then you go first into first. So x squared goes into x squared, which a lot of times I do that over on the side. X squared over x squared. This one's pretty easy. I get 1. I multiply here and here. So I get x squared plus 1. Then you change the sign because you're subtracting. So I just like to change the sign and then add. So those are going to cancel and those cancel, which those don't always, but those always do cancel. And we just get x. Now that's it because x squared doesn't go into x, so we're done. So now you just write it as an improper fraction. So this now becomes 1, that's the whole number, plus the remainder over the divisor. Let's say you forget that on the side and you can't remember like how to turn this into it. So like let's say I do 17 divided by 2. What is that? That's 8 and a half. See? Because 2 goes into 17 8 times, multiply, subtract. See, that's what I'm doing here. You get 1, which is your remainder. So that goes there over the divisor. 8's your whole number. So I always just think of an odd number divided by 2 in my head, but I'm still thinking of that. And then I'm going, oh, right, that's the whole number plus the remainder over the divisor. Okay? Now let's try it again. Well, you can certainly do this part, even if you can't do the other part. Okay? What's the antiderivative of 1? Well, that's just x. Okay? Plus, well, let's say plus c. Plus the antiderivative of x over x squared plus 1 dx. So, I could at least get half credit, even if I can't do this one. Okay, now, try again. Well, that would work with their u sub because I'd get a 2x, and that's the whole denominator now. The whole numerator now. So u equals x squared plus 1. Du is 2x dx. So I need a 2 here. So if I put a 2 in, I got to take a 2 out. Now I have 2x dx. All of that is du. And that right there is u. So now I get 1/2 the integral of 1 over u du. Don't forget your x plus c from up there. Okay, and then what is the antiderivative of 1 over u? Well, it's natural log, so I get x plus 1/2 ln of the absolute value of u, and then I like my plus c at the end. You would have a plus c from this one and a plus c from this one, but 2 c's is just a new constant, so that's good. Okay, and then u is x squared plus 1, so I get x plus 1/2 ln of x squared plus 1 plus c, which normally I would leave my absolute values, but x squared plus 1 is positive. You would not be docked if you just left your absolute values. I just can't help myself. All right, let's do another one. Let's see, the antiderivative of x cubed minus 3x squared plus 1 over x squared plus 1 dx. Okay, so again, this is improper. See, the 3 is bigger than the 2, so it's improper. Okay, so first of all, I'm going to try u sub. That'd be 2x, not the top. So I just did that in my head. And then x squared plus 1 into x cubed minus 3x squared plus, now don't forget this part. I mean, if you do, it won't mess up. It's not like you'll get the problem wrong. If you were doing synthetic division, you would. But anyway, it just makes the spacing nicer sometimes. Plus 0x plus 1. See, 3, 2, 1, nothing. I like to have all of them there so that I can line stuff up. Okay, now over on the side, that's x cubed over x squared. First into first. Well, that just gives you an x. You don't have to line it up here. You can put it there, like in the previous problem. I did not line the 1 up over the 1. I just put it right in the front. A lot of people put it what it lines up, and then you know you're done when you run out of things to line up over. Okay? So it really just depends on your preference. All right, now we do this times both of those. So we get x cubed plus x. Now you change the sign and add. So those cancel, and I get negative 3x squared minus x plus 1. Now you do first into first again. So negative 3x squared over x squared, and you get a negative 3. Now multiply again. I'm not going to draw the arrows again because that gets really messy. Negative 3x squared minus 3. Excuse me. Okay. And then I'm going to change the sign, which I like to bring my other color in. Otherwise, you might forget where those came from. And then I get negative x plus 4. Okay, I've run out of room up here because I lined them up this time. X can't be divided by x squared. So I'm just going to write it as an improper fraction now. Remember, it's quotient plus remainder over divisor. Okay? So this becomes the quotient, which is x minus 3 dx plus, see, this time I'm writing it as two separate ones. Again, with this one, I wrote it as the improper fraction and then did them. Okay? This time I'm choosing to write them as the two separate things because this one's going to generally be easier and this one's going to be a little bit harder. Okay? Plus remainder over divisor. All right, this one I got for sure. That's 1/2 x squared minus 3x plus c. Now this one, I'm not too sure. Let's see, u is x squared plus 1 Well, then du is 2x dx. Don't really know. That doesn't help. It's not improper. Oops, sorry. I think we're going to have to split it up. So, like, let's just split this again. All right, so now this is going to become the integral of negative x over x squared plus 1 dx. See, because now I can do that one with a u substitution. Plus the integral of 4 over x squared plus 1 dx. That one I'm not so sure about, but let's just worry about one at a time. Like, I got half, well, no, I have a third of the problem. I'm going to get ready to get 2/3 of the problem. I'll worry about that one later, okay? All right, so this one, I need a 2, so I'm just going to multiply a 2 in and multiply a half out, right? Okay, so now, not the negative, but the x and the 2 and the dx make du. Now I'm going to pull that negative out, so that's negative 1/2 1 over u du, which is negative 1/2 ln of u plus c, which is negative 1/2 ln of x squared plus 1 plus c. Yes, getting there. Now this one. This one actually is in, oh, I hope I have that page. Yes, I do. Sorry. You have that page. It's in your memorization stuff. Find that page. Okay. It is right there. X squared plus 1. See? U squared plus 1. It's arctangent of u. I mean, you don't need a u for this one. U is x. But this is just 4 arctangent of x plus c. So altogether, my answer is 1/2 x squared minus 3x minus 1/2 ln of x squared plus 1 plus 4 arctangent of x plus c. Woo! That one was fun.